We've got, this turns out, 4 speakers on the program, and I was instructed to dispense with a formal introduction. Our first speaker is Paul Garver, who runs our warehouse down in Deptford. Now, you can laugh if you want to, but in '57 when he took it over, that's about what it was. It's come a long way since then, and I think you'll see that as the program goes on. So, Paul.
Thank you, Bill. Bill told me he was going to use that introduction, and I told him to go ahead, and I guess I underestimated that he was really going to do this thing. I've got a title, I guess, general manager, and it reminds me of the fellow went out to go hunting out in Midwest. Went out and he picked up a guide, and the guide offered to give him a dog to go out and do his hunting. The dog's name was Assistant. It cost $10 for the dog for 2 days, so he went out, and in 1 day he got his limit of game. So the next year he went back and he picked up the same guide, and so I want that same dog, Assistant. He was real good. The guy said, well, it's cost you $20. He said, well, last year it was 10. I said, well, this dog is so good that, you know, I can name my own price. In 1 day he got his limit of game. The third year he went back and the dog cost $40. But again, he got his limit of game. So I went back the fourth year and he asked for the same dog, and the guy said, okay, that's fine, but it'll cost you $2. He said, $2? Geez, last year it was 40. He said, well, said, I'll tell you what happened. He said, some darn fool took that dog out and ruined him, and he called him manager, and all the dog wants to do now is sit on his tail and bark at people. About 2 years ago, I was up here, and I was then the manager of the Parts and Accessories Division. And at that time, I told you that we desperately needed new products to maintain the viability of our business. And expenses were increasing, and our rate of sales growth was not keeping pace with it. And we were getting into a position where unless we found new products, we couldn't maintain the profitability of our division. A lot of things have happened since then. Parts and Accessories no longer exist. We were merged in with the Distributor Products Division of the Electronic Components Division, and we formed the new division now called Distributor and Special Products Division. And when the merger took place, we analyzed each business that we were in, and we decided that the test equipment business did not offer any potential for profit for us in the future, so we sold that business about a year ago. The same conclusion was reached on the battery business, and having nobody to buy it, we just abandoned the battery business. But we did pick up and continue with the receiving tube business, the picture tube business, and the solid state replacement business. And as a result, we now have a much broader base over which to spread our fixed expenses. And a byproduct of this merger, of course, was increased profitability. But now, 2 years later, we stand facing the same problem we had before. We have to look for some new products and new businesses to get into to maintain the viability of our total business. And I'd like to show you a little bit where we stand on each of our businesses at this time. And we are, in effect, a little conglomerate of a lot of different businesses. So if we can have the first slide. All right, got to go back, missed one. Our primary function is to provide replacement parts for the products that the corporation markets. And here's a chart that shows the replacement parts sales, our sales, for the last 5 years and what they're projected to be for the next 3 years. Now, this business is considerably larger than it was 10 or 15 years ago, but when you back out inflation, you can see that there isn't a tremendous growth in this business. We have just about reached the limit of our penetration of the market in this business. The only thing that's really helping us in this is that we are now getting into more proprietary components. As we get into modules and things like this, they're not available from other sources. And you will see that this is a good, solid business, but it's not the kind of a business that you look to for growth. There's no way to get industry figures on this since it covers such a wide variety of components. But this is the main part of our business and our main responsibility. A second piece of our business, which represents even greater volume, is the receiving tube business. Now, everyone concedes that the receiving tube as we know it has a very limited life. Solid state has taken its toll and has completely eliminated the use of the receiving tube in any new products being manufactured. And all that's left in the receiving tube business is the replacement market. As you can see from this chart, this market is tapering off steadily as more and more people replace older equipment with solid-state devices. Our share of this market is still good, but there appears to be little chance of increasing our share over the next few years. As you know, we could not afford to operate our receiving tube manufacturing plants with this low volume, and we are now in this business on a buy and sell basis. It is a profitable business, but certainly not the kind of a business you would look to for any growth. We are now competing with our suppliers in the marketplace, and only our reputation and our service are enabling us to maintain a reasonable market share. In effect, the walls are closing in us, and we cannot look to this business to absorb any inflation in our costs. A third business which we now have is the picture tube business. And here again, the only area of this business that we engage in is the replacement business. And much has been done in recent years to improve the quality of picture tubes, and as the cost of the picture tube goes up, it becomes easier for the consumer to purchase a new set instead of replacing the picture tube. And although this business has a fairly stable pattern as an industry, it doesn't offer much as a potential for growth in the future. And it's extremely difficult to increase our share of this business because of the competitive pressures. A fourth business that we are involved in is the sale of antennas and antenna accessories. And here again, this is a good business, but it does have its problems. When the economy is soft, people tend to make do with their existing antennas, unless a windstorm or something forces them to buy a new one. As cable TV makes further inroads into the industry, we look for no growth in this business. This industry is full of small manufacturers who make antennas locally and offer great competition to us. Now, a few years ago, you people in Princeton worked with us and developed a new antenna called the mini-state antenna. And this has been a real good item for us. It has not accounted for a large sales volume, but it did give us a prestige item in the line, which has improved our image and helped our total penetration in this market. We have a reasonable share of the market in this business, but competition makes it extremely difficult to increase that share profitably. We cannot look to this business to absorb increased expenses in future years. In analyzing all of our businesses, we decided several years ago that we had to find a new business area in order to obtain the growth that was necessary. And at that time, we started into the auto sound business. Our first venture was with Stereo 8 tape players, and we have since moved into cassette players, AM/FM radios, and combinations. This chart shows you the potential growth of the auto sound business. Now, we in RCA have nothing unique to offer in the way of a product. We are buying from offshore manufacturers, and we are offering to the customer the same product that is being offered by our competitors. We have two opportunities in this business. The first is to capitalize on the name RCA and the service and reliability that that name implies. And the second opportunity is presented by the automobile manufacturers who up until now have priced their radios in such a way to give us a lot of room to sell product at a lower price and still maintain a profitability in our business. This business has been good for us, even though our share of the market has not been great. We could find that we cannot make money in this business in the future if the automobile manufacturers reduce their prices substantially, or if one of our competitors introduces a technological breakthrough which enables him to sell products with new features or better pricing. We do not look for a large share of this market, but again, it does contribute to our total business. During these last 2 years, a new product has bloomed in the electronic industry. It has had the most sensational growth of any electronic product in history. This, of course, is the Citizens Band business. Here's an industry projection of the CB business over the last 3 years and for the next 5 years. It does show a tremendous growth and a continued good business trend. We entered the CB market in 1976, and at that time it was a seller's market, and it was almost impossible to buy any quantities that were necessary to meet the market demand. This all happened so fast that the only way we could get into this business was to find an offshore manufacturer who was in the production and who was willing to give us some share of his production. We started out with the crystal type units, and in July we received our first units using the phase lock loop. Of course, as you know, the FCC decided in August to expand the CB to 40 channels. And just as we were starting to get product quantities to send to our customers, the demand dropped off and our competitors were stuck with extremely high inventories of 23 channel units. The problem in the industry is that almost everyone is dependent on offshore production. This means that everyone had long delivery cycles and high inventories. And even if the 23 channel production could have been shut off immediately in August, there was so much product on the water and in inventory that it was impossible to sell it off by the end of this year under normal business conditions and pricing. We do have some excess inventory of 23 channel, and we've had to cut prices sharply, but we are in relatively good position. We hope to enter 1977 with a minimum of 23 channel units and a good mix of 40 channel units to sell to our customers. It's extremely difficult to move fast when you are completely dependent on Japanese vendors with the long delivery cycles and the need to carry high inventories on a product such as this. We do feel that we can gain a significant share of this market, and it does present some growth opportunities to us. Our big problem with CB is that we at RCA have nothing distinct to offer, and we are faced with complete dependency on Japanese manufacturers. It's going to be extremely difficult to maximize our penetration and profits on this business. But we need growth so badly that we cannot afford to ignore the Citizens Band business. Now, about 2 years ago, we started working with some of you people on another new product. At that time, the product was identified as Fred. We recognized the potential, and we gave you a challenge to develop this product in such a way that the price would make it a consumer item. You met the challenge, and next month we will introduce a new product as Studio 2. Now, obviously, we were not alone in developing this product, since many other manufacturers have already introduced TV games. This chart shows the market potential for TV games in the future. It's interesting that this market is breaking into two significant categories. The first group involves the unsophisticated ping-pong hockey version, which has been highly advertised. It's our feeling that this part of the market will become very price competitive and will end up in chaos like the calculator business or the electronic watch business. We have no intentions of entering this part of the total market. The second part of the market will require a more sophisticated version using a microprocessor. And this will give the product greater flexibility and utility, and will become a more desirable product even though it will maintain a higher price. By working with people here in the laboratory and with our own engineering department, we have developed Studio 2 to the point where we have received FCC approval, we are in production, and we hope to introduce this product early in 1977. We thought it would be appropriate to demonstrate this product to you in its present version. And I've asked Fred Wenger later on to run a demonstration for you. Now, we recognize several things about this product. First, we think it is good. We think, however, that to stay competitive, further innovations will have to be introduced next year. We feel that we will need the addition of color, the addition of separate controls, and we feel that competition will force us into these and other features not included in the present Studio 2. There undoubtedly will be a Studio 3, a Studio 4, and possibly a Studio 5 version in the coming years. But we are very dependent on you people in the laboratories to help us develop these features and improvements. And now I'd like to ask P.K.Baltzer to come up and explain to you in your language a little bit about what makes this little marvel work. Bill?
Now, it can be told that over 5 years ago, while the RCA Corporation was dramatically phasing out of mainframe computers, that there was a rebel named Joe Weisbecker who single-handedly was trying to phase RCA into the microcomputer business. His system was thinly disguised with the name Fred. The first slide, please. Flexible recreation educational device. Of course, it wasn't a computer. Now, microprocessor-based systems are complicated by the fact that the system can have a multiplicity of functions, and each of these functions can be implemented in a multiplicity of ways. Therefore, it's necessary in order to produce a cost-effective product, to develop this in evolutionary stages. This enables us to build and develop the necessary experience base. If we try to leapfrog, say 5 years, it's very dangerous, because the set of functions we may define and the way of implementing them that we may define may be not cost effective or competitive 5 years from now. The Studio 2 system we're about to describe represents the 6th generation of Fred. And we'll discuss the unique features of the system design, component design, and software design. I'd like to have the next slide, please. This system is really beguilingly simple. It consists of 13 chips as compared with the latest competitive product of 40 chips. It's a true computer in the sense that it has a processing unit, memory, and I/O. The memory consists of 2,000 bytes of ROM, which I'll discuss in a little while, 512 bytes of RAM, a TV chip which takes information from memory and puts it out in video format. The microprocessor has a built-in flip-flop, which can be set and reset on the program control. This is used to turn off and on an oscillator, which drives a speaker. The keyboards of our system are interfaced in the following way. 4 bits, or half a byte, is sent down to a decoder chip, 4515. And this decoder chip has 16 outputs, any one of which can be brought down depending on the code sent into it. We only need 10 because that's how many buttons we had on each keyboard. So 10 of these are brought to each of these buttons, and then a common return brought back to a flag for one and a different flag for the other. They are in parallel here. To show you how this works, for example, suppose we have a program in a processor which sends down a sequence of different combinations of bits. And after each bit, it takes a look at the flag. Suppose we start with 000 and then go 001 and so forth. And, and so it goes in this loop. It sends down data, looks for a flag. And now, if we go over and press a button here, say the 5 button, and then it finds that the flag 3 is changed. It stops the loop, looks to see what that code was it sent down, and therefore it knows it was the 5th bit button that was pressed. Now, the only component here which is unique to this system is the TV chip. And it also is an extremely simple chip which exploits the features, unique features of the Cosmac microprocessor. It's simply a timing chain with an 8-bit, single 8-bit shift register. The timing chain counts down from the common clock. There's clock, this is common to the chip and the processor so that they're synchronously related. And the timing chain develops horizontal sync, vertical sync. It develops also signals to interrupt the processor from normal programming. Also a direct memory access signal, which I'll explain a little bit, and flag 1. The information when on the DMA takes data which is in the RAM and pipes it out in sequence to the TV chip. And as each byte is sent out to the TV chip, it goes into that single 8-bit shift register, which is then shifted out by the clock oscillator, which just happens to be 8 times the machine cycle rate for shifting bytes out. And therefore we get a video signal coming out which represents the bit pattern in memory. Let us look at the next slide here, which shows schematically what a TV frame, a video frame is like. This should be 80 lines up here at the top. The frame consists of 262 horizontal lines. We do not interlace. And during the display area shown here, the time from this point to this point, the processor is tied up full time, supplying refresh information to the TV chip. During each horizontal period, during this display area, 8 bytes are sent out in sequence during this period, as indicated down here, 0 through 7. Each of these 8 bytes is, as I said before, shifted out of the 8-bit shift register and provides a total of 64 bits resolution across this way. Vertically, we have 128 lines, which in the Studio 2 system is used so as to give 32 lines of information. So we end up with a format 32 bits this way times 64 bits that way, or a full page that is 256 bytes of information mapped out on the video frame. As we go in time, around here, the microprocessor receives an interrupt signal which stops its normal processing, and then the DMA signal comes up during a horizontal line. At the end, the flag is changed also, and this tells the processor that it's through showing the display information that can go back to regular programming. The dedication of processor to this area requires that 4/10 of its total time is spent refreshing and 6/10 of its total time is spent implementing the program. The third unique feature we want to talk about is the software. I'd like to show the next slide. This shows the ROM area used by the software built into the system as you would buy it. The first 1,000 bytes of ROM define an interpreter, which I'll explain in a moment. And the next 1,000 bytes define the particular set of games that are in the system we call the resident games. Now the system is so designed that there is an external socket provided so that you can plug in external ROM which will electrically replace this section here, so that you can change the function by just plugging in an external ROM. Next slide, please. Most of you are familiar with a compiler. You write a program, a source program in COBOL or Fortran, It is then compiled into an object program in machine code, which then can be run to implement the program. Now, an interpreter is different. This is your source program here. Interpreter analyzes the source program and then implements it directly with a set of routines built into the interpreter. It then goes back and gets the next operation from the source program and so forth. Now, normally, if the source program is written in a pseudo-English, this has to be interpreted, that is, the English has to be interpreted. It's called parsing. And if you're in a loop, an iterative loop in a computer, this parsing time can be tremendous handicap. Also, the source program takes up a great deal of space in memory. So to solve both those problems, the interpreter was designed so as to define a pseudo-language which is numeric. It looks like machine code, but it's really a high-level language. And an example, a typical example of some of the codes are shown in the next slide. The first thing that was done was to limit the number of variables to only 16 variables. This means they can be identified with only 4 binary bits, or a half a byte, or we would say a hex digit. Next thing was to reduce the program size to no more than 4,000 bytes. Now, an address within that number can be defined with only 3 hex digits, or in other words, 12 binary bytes. This enables one to design very compact opcodes. For example, this one here, 0MMM, where these M's can be any hex digit. It's just a straight go-to, conditional on the fact if the variable 0 is 0, and so forth. 1 is a similar if it's not 0. 2MMM is a call for a subroutine. At the end of a subroutine, 30 instruction is used, which returns you to the original calling location, and so on. And then you got put a constant into a variable. We got some arithmetic. Down here, a type of opcode we found very useful, generates a random number, a pseudo-random number. It masks it with a constant kk and deposits it into variable x. This is very convenient for producing a program which depends on probability and enables us to make a game much more interesting. Further, we usually have a opcode like this, which enables you to go to a machine-coded subroutine anywhere in memory. This enables you to tailor any system to a particular case you have in mind. And then we have other opcodes which are designed explicitly to handle bits in the display area for the TV interface. This package enables one to create very efficiently codes for games. Now, I'd like to show an example where you compare this with something done with an assembler. Next slide, please. Here, you plot complexity against program size. And this is what you would have for, say, a machine-coded program as a reference. Now, if you go to very low complexity, you pay a penalty for the overhead of the interpreter. But as you go out, you very rapidly get a more efficient system. In our system, you have about 2,000 bytes of ROM. You're out here, and this is comparable to what you could do with 8,000 bytes of straight machine code. Further, this interpreter is shared by all plug-in units, so that our plug-ins, which will be a larger number than the initial system, can be done very efficiently. Next slide, please. RCA is traditionally a very conventional company. And it's surprising how conventional we all are. But seriously, this is a good, that is morally good field, business. If you you put this in a family, you see mother and child, husband and wife getting together. Further, it's a viable business. It's not something for RCA to be ashamed of, to be in this business. I'm serious. And the fact that it can provide the largest single market for RCA IC chips could even be incidental. The next speaker is Dave Callaghan, Chief Engineer of the Distributed Special Products Division. I think he has to be commended for his courage to be willing to take the quantum leap between TV antennas and microprocessor systems. Dave.
Thank you, Phil, and good morning. This was a rather new venture to us, as Phil mentioned. We are basically an analog house, antennas being analog devices, and of course a lot of them are mechanical devices, and CB sets, car radios, and the other tape players are all basically analog items. So this was our first exposure to a digital device. That may sound kind of strange in the age where digital devices have been around a long time, but again, if you look at the television division, they have the same situation. They have a few little push-button jobs to program the set, and that's their digital introduction at the moment. And there are a lot of times when I hoped we had gone with a little simpler digital device for our first one. Somewhere down here in the audience are two of my fellows here, and later on you may have some questions. One is Bill Bachman, who's a senior mechanical engineer, and he is also the project engineer on this item, and Bill Stonecker, who is the electrical engineer, primarily specializing in the digital end of the game, and of course works very closely with Phil and Joe Weisbecker. I wanted to give you a little idea of what we have done here, and I know that there is a game here, and a lot of you may not have seen it, and I'll show it to you on slides, but it is basically a small cabinet with the two 10-digit keyboards and a socket into which additional programs can be inserted. The game has in it the ROMs which include 5 games selectable, and you'll see that a little later. Internally, and then additional ones, of course, can go inside. This is part of our type of business, plastic housings, the type of design, and we went through this. The other parts of the game gave us a little more trouble in the fact that we have designed a modulator to go with it, and there's some interesting stories I'm not going to bore you with this morning. In trying to get through the FCC, they have put some very, very strict requirements on the game. One of those requirements, for those who are not familiar, that this may not radiate on any frequency, and of course particularly those frequencies of the TV signal where the cord goes down and goes into the TV antenna terminals, more than 15 microvolts per meter at 1 meter, and that is a pretty low signal level. We have, in order to allow the customer enough cord to get the set away from the TV set, an 18-foot cord, and the radiation from that cord alone was rather difficult to stop because of small induced voltages coming out of the machine. And we thought we had done a very fine job on it until we got down to the commission and saw how they tested them. We feel that somehow they have a thing about Class 1 TV devices, which are video games. They took the game cord, the coaxial cable, and arranged it in any fashion they could to make the unit exceed the 15 microvolts per meter. And one of the ways they found most effective was to arrange the 18-foot coax into a folded dipole. They actually do this. You know, this isn't funny. We made the first game and draped the cord out across the floor and up to the TV set. And of course, the first thing we found out was that we couldn't even measure the radiation from the game because that coming from the TV set was about 10 times as strong as the amount allowed from the game. But we got the, you hook it to the termination, but you can't have a turned on TV set within 30 or 40 feet of it. And we did this and we thought everything was fine until we found out that these guys make folded dipoles out of the cords and the power cord as well. And one of the features of this unit is the fact that we run the power in the back. I'm getting a little ahead and I'll show you slides, but in the back of the set there's a switch. The switch is the input from your antenna to the input of the Studio 2. And most other people who power there either have batteries or they power the game with a separate plug-in cord, and that meant two cables, one coax and a power cord. So we decided to run the power up the coaxial cable, bring the power in back of the TV set into the switch box at the antenna terminal, run the power up the coaxial cable to the unit, and of course run the RF back down again. Well, this is a fine idea, and I think we have a good advantage, and we first took it to the commission, and the fellow said, where's your power jack? And I said, oh, it comes back up the coaxial cable. He says, oh, the power is in the same cable as the RF, and I said, that's right. And he said, and that in turn goes back to the 120 volt line? Yep. Says you'll never make it. So, well, we did anyway. And to give you an idea of what has happened, if I can have the first slide, please. Here we have what I held up to show you. We have the basic Studio 2 console, and what you see now is just the coaxial cable, 18 feet, or what is many times now called the game cord. This breaks it down. Now I've jumped back to the beginning, and in the game, or in the unit, I'm not supposed to say game. This is a more sophisticated device, but we're starting out as a game, and it's going to develop into, I'm sure, a lot of other things. There are 222 component parts, and they're all laid out here. It might be interesting to note that the chips, the first four that you see are ROMs, then RAMs, there is the microprocessor and the TV chip. Those are the single most expensive component in the game, accounting for almost 50% of the cost. However, if you break that's the group. If you break them down individually, the microprocessor is the single most expensive component, and surprisingly enough, the second most expensive component is the PC board. This is a glass double-sided computer grade board, and I'll show you some detail of it, and it is not cheap. So we must find ways to combine functions to get more density in the chips and get the board down. It's a very expensive item, and we're looking for other constructions. But that is everything that the factory starts out with to put together the unit. Now here is the main frame, if you want to call it that, or the main PC board, and all of its components distributed around. It has a little loudspeaker. We opted not to try to send sound down to the TV set because for our first attempt, another 4.5 megahertz space carrier is just another one that has to be suppressed. I think this later versions we will certainly do this. All of these pieces go together. The metal parts you see over here are a shield can and a top and bottom lid for the modulator. The modulator is this area that has a lot of copper on it, is built as an integral part of the board. So now if by some magic we can throw all these parts together, well, sorry, flipped one here. This is the PC board in a little more detail, the front and the back. So you can see both sides at the same time, and you can see there is a lot of copper all over the board and a lot of traces, and it took a sizable amount of layout. And of course then we worried about coupling between paths, and we had to do a certain amount of relayout and bypassing. Now we've thrown everything on the board, and this is what it looks like. You can see again the 4 ROMs, the 2 game ROMs, the 2 interpreters, the 4 RAMs, the microprocessor, the TV chip, the boards that scan and select keyboards down here. There is, by the way, not a single discrete transistor in here. Everything is on chips. The modulator has all the little filters and capacitors and one small 6 transistor chip that does RF oscillator and modulator. And around the corner are 2 more, the audio chip, which makes sound for the loudspeaker. You see the back of it over here. And we have an onboard voltage regulator. We develop 9 volts in the power supply, send it up the cable, and reduce it to 5 with a onboard regulator in here. This is to get spikes and surges out and keep us some good voltage. We're very, very conscious of static discharge problems. You will notice that there are ground area paths all around the board. Even down here where the keyboard sockets are, we did bring those out for another reason, but subsequently, this is an early board, we have wiped the ground path right across this point as well, so that any place you approach the board from the outside, the first thing that you do is hit the ground side of the circuit. We now come to the keyboard. The keyboard became difficult, and it sounds funny, but we looked and you say, well, we needed a couple of cheap keyboards. Cost is very much our goal here, and we do have a very costly system, and we have to keep other components to a minimum. We went out and looked at calculator keyboards, and the little handheld ones, type ones, were cheap, but they were both too small for our application and not very rugged. Then we looked at telephone type keyboards, which are exactly what we wanted, and they come at about $4 a piece, and 2 keyboards is $8. That costs almost as much as the microprocessor, and we couldn't afford that. So surprisingly enough, with all the keyboards around, we designed our own. And this is the keyboard. There's a plastic part with all the keys molded in. And for Joe Weisbecker's information, these 2 blanks do have keys in the mold, so we can go to 12 keys in later versions. We then made a PC board, had an outside company specializing in this, do a PC on Mylar with little bubbles that give you oil can buttons. That folds over, has a spacer in between to keep the board from shorting out, a rubber pad, and is activated directly here, and of course a number overlay over the top. And that is the whole keyboard assembly, which cost us somewhere less than $1, or is about in the cost, is cost competitive with little handheld calculator boards with much smaller buttons. Now we need a housing. We have the top housing, and I show you both views of it, the face of it and the underside view showing all the mounting bosses, and the little hardware and the clear switch and an LED indicator light, which become part of the housing assembly. Here we take the housing, and you can see an assembled keyboard, a bottom view of the circuit folded over, a top view of the keyboard, one being slipped in. The printed circuit tab just goes through a slot, and the keyboard then snaps in place. There are no no fasteners. The installation of this is about a 10-second operation to install a keyboard. We turned it upside down, the housing, and now we bring the main PC board, and the tabs for the keyboards come through the slot and are put in the sockets both sides. We have an LED indicator and a clear switch, which is the only hard wiring on the board, which connects 3 wires back to the main board. We then just flop it over from the other view, just flop it over and lay it down on top of the housing, and it is now in place. And of course you see the shield cans are now in place on the modulator. At this point of time, it's fully assembled. Of course, we do a lot of testing in between, and we're indebted to Phil Baltzer's group and Tom Chen who have been working very diligently on a test program for this. It's not an easy thing to test. And at this point, we come to the bottom of the housing. The bottom of the housing has 2 slots in it, one to switch channels. Our output, by the way, is on channel 2 or 3. And you can put a screwdriver, ballpoint pen in here and hit the switches, which, if I back up one, oh, that was enough. You can see the switches. One is the channel select switch, and the other one is to cut the sound off. We felt that some mothers may be very uptight about this beep beep going on all day long, so we hit a switch in there where they can shut it off. And in addition, the lower housing, of course, are the labels, the feet, and mounting screws. And we put it together, and this is what you started out with, the first slide. And now we have the accessory items. This is a switch box, which goes back of the TV set. And just to show you that even a box is not so simple, we have tooled a little metal box into which the selector switch and the ballon and the filter and the power supply plug. And this whole thing here is a pre-painted piece of steel, and that is the die. This is a shot from the die, and that's how you progress through the die to fold up this box, which you see at top and bottom view. So from one automatic die, we start with a strip of steel, pierce it, come out, and fold it up, all ready for riveting. That's the first step, is make the box. Of course, we make the plastic housings as well that you saw as part of the main part. And here is the switch box. We have the box and a lid for it, which I didn't show you. That's another tool. And inside the box, we have a slide switch, which must have 60 dB of isolation from one side of the switch to the other, again to meet FCC. Rivets to put the box together, plugs, terminal boards, capacitors, chokes, ballon, and a piece of lead wire. That suddenly all goes together, and this is the switch box. You can see inside of it where the switch and all the little components go. And you'll notice there's a big space in here. This is a 60 dB isolation. You can't have any wires looping around. And here it is with a lid on it, with a label, as it goes on the back of your TV set. Now we put it all together, and what comes in the package is the main part of the game. The switch box that goes in the back of your TV set has a little piece of sticky plastic that you can glue it on with after a while, and a power supply. The 9-volt supply plugs into a power jack on the switch box. So that is the complete assembly. This is what the customer will get, and this is how he gets it. It's in a foam pack. This is the lid, and the box and the component parts nest down underneath. And this is the game as it arrives. Now you notice that we had a socket, and there are 2 metal pins, so that after you've seen this part of it, we now provide plug-in games. Again, we have 2 ROMs, a PC board, a couple of select diodes, an upper shell, a lower shell, 2 labels. These labels are blank because we haven't any with the final printing on them. some rivets to put it together, and here we have a rather unique device. This is a stainless steel spring that has a lot of fingers on it. Bill Bachman has one with him that any of you are really interested can see in detail. Problem being that when we put this together as a plug-in unit, the contacts for the PC board stick out of the end and are accessible to human hands, static discharge, and everything else. This is an assembled one back view, front view, and here's one with the half of the cover off. And you'll see the function of this spring lays inside here and has a little finger which shorts the whole board together in one shot. When you insert it in the game, there are two posts that go up in the holes. Either side are guide pins that guide this thing in place, and that lifts all the spring fingers off of the contacts to activate the board when we go inside. As I mentioned earlier, static discharges have been a real problem in any device of this type, in particular CMOS devices. To date, we have not had a single failure from any type of static discharge. I'm sure someone will find one big enough to make it happen, but we have been pretty fortunate so far. And this is the unit complete with the cartridge for additional games plugged in. So we've tried to give you a little build-up of the unit, and if I can have the lights, please. Thank you very much, and I hope I gave you just a little quickie of what we've been doing for the last 11 months, trying to design all these parts and get them all assembled into one piece. Paul? Fred?
Yep.
We're going to make a little demo. As you can see, the combined Princeton Deptford engineering group with help from Somerville, I think, has produced a product that we can all be proud of. I think if you look at our major competition, which is Fairchild, you'll be even prouder of the job that was done on this product. The key, as you probably have already are aware of, will be the software development. We've depended so far on Weisbecker and Baltzer, and they've done a good job. We now have Andy Modla, who's on our payroll, but working up here in Princeton in the continuing software development. So if we can, let's show you the 5 built-in games that are part of this original package. Essentially, we'll call the first one up here, which is bowling. This is a 10-frame bowling game. This cursor that goes up and down essentially is the ball, and we can release that when it's in the proper position. Now I can throw a straight ball, I can hook the ball up, or I can hook the ball down. Now this digital keyboard, I don't know if you noticed it or not, but there are directional arrows, so that if you want to go hook it up, I would hit this top button right here, and it also has an indicator that shows that it's moving up.
You missed the head pin, Fred.
Well, I don't want to make it look. Okay, that's my frame, and you'll see I scored 9. Now the next player uses the B keyboard, and I'll play better from this B keyboard. But not much.
Put it here, please.
All right. I don't want to make this thing look. Okay, at the end of the first frame, 9 to 7. Now we'll show you how to really do it. Nope.
Missed the head pin again, Fred.
Now, that is difficult to do, to miss all of those pins, but I accomplished it. Okay, this is 10-frame bowling. Another game, and we'll move right along in the interest of time here, is a racing game. Now here we have a car that I'm going to drive, and I'm trying to avoid hitting that car ahead. Now this is a 2-minute race, and at the end, every time I strike the obstacle car, it slows me down. At the end of 2 minutes, you'll see on the screen the number of miles that I've traveled. Okay, I'll start the game out by hitting 0, and I'll go at a very slow speed, you'll notice. And I'll steer back and forth. Now I'm getting good, so I'll speed the thing up. I can't hit pins, I can't hit cars either. There I go. But that'll slow me down. Now, just when you think you got it, you know. Now, in addition to that type obstacle car motion, once you think you really have it, you can initiate the game. I initiated the game by hitting the B0 keyboard. If that's too easy, there's another degree of difficulty on the obstacle car, and I start the game with A0, and that makes it more difficult. So you have several levels. I can adjust the speed so that a small child can move the car through easier, or I can adjust the degree of difficulty as far as the obstacle car is concerned. Okay, we clear and bring up number 1, which is essentially an Etch-a-Sketch type thing. It's an electronic blackboard, and I can move that cursor across the screen. Now I want to write, so I'll push the 5 button and start to write. I can go up, I can build a house, I can go diagonally, swing it back this way. And once I get some kind of a fancy symbol, I can kind of wipe the screen by, in other words, if I wanted to draw a Christmas tree, for example, and keep constant movement on the screen, I'll wipe that up. You'll notice when I go across something that's been written over, it'll change it. It's the negative positive effect on this keyboard. Anytime I want to stop it, I can stop it, or I can continue the movement. You can write, you can erase. As I say, it's an electronic blackboard for the kids. Now, the intent on this first package was to try to give a little bit for everybody. You have some action type games, you have the doodle type game. In addition to that, we have a computer generated pattern game. Now, I can move a cursor, then I can move it in that direction. I want to start writing that little thing, and it'll just continue to repeat across the screen. And this will give you interesting computer type generated patterns. As it goes through the second time, it'll erase what had been written. You'll notice we'll come up with dots now. Eventually, this keyboard, or pardon me, the screen will end up with a bunch of large squares. Now I can give 130 different patterns, just to give you an idea of some of the other things that you dream up your own pattern. Okay, I'm going to start writing just for the heck of it. Get all sorts of strange things. Now this, when you first start playing with it, doesn't appear to be much, but believe me, you have an awful lot of fun generating different type patterns. Eventually it'll all come back to where it started if you wait long enough. And, okay, the last one on the built-in game is what we call an addition, or what the fellows at programmed it called some fun. We call it an addition. Now this is a combination of addition and kind of finger dexterity. I'm going to add those 3 numbers, 3 plus 1 plus 3, and get 7. And,
Too late.
okay, I enter that into the keyboard. Now, 2 players, one against the other, you can compete, or if I'm alone, I can compete against the computer, because the faster I add that sum up and enter it into the keyboard, the higher the score. Now, 8, you'll notice if I do it fast, now I'm going to wait for a while, my score on this one will only be 5. If I do it real fast, it was a 10. I think the maximum score is 11. So if you play against the computer and you get 200, it's a very fine score. And as I say, you also have the competitive nature the aspect of two people competing against each other on the unit. Okay, now can we have the lights up for a minute? Okay, that's the 5 built-in games. All right, now we're tired of those. Any other game, you're locked in with what comes with a unit. And most of the people that we've talked to, the unit ends up on the closet shelf. The people that have Pong play it for a month or two, and then it ends up on the closet shelf. Now, when you get tired of the basic units, we'll supply plugins that Dave described, and this essentially will be the plug-in. We'll have 3 color codes. Initially, we'll have what we call a TV arcade series. That will include the action-type games. We'll have a TV casino, which will be games of chance. We'll have, the fellows are working on poker, blackjack, acey-deucey, roulette, horse racing games. And then we have the thing that I think will really help sell this thing, and that's the TV Schoolhouse series. We'll have educational type programs. Okay, the first one that I'll put in is one of the arcade series. And all you do to change games, plug this thing in and clear it. Okay, this is a 2-program game. The first one is a space war type game. Whoops. What do we got? Actually, this is another type game. It's fun with numbers. The computer will generate a 3-digit number, and I'm supposed to try to guess that number. So I'll enter my guess, 3. Now that tells me I have a score of 2. It tells me that either 2 of those numbers are right. In other words, I score 1 if the number is right but in the wrong position. I score a 2 if the number is right and in the right position. So I got 2 on 1, 2, 3. Let's see what 4, 5, 6 gives me. That's 2 more there. So I'll try 7, 8, 9. Well, it's not one of those. And I'm going to try, just for the heck of it, a 0, 0, 0. It's not one of those. So the 2 numbers are in 1, 2, 3, 4, 5, 6. So let's see, 1, 2, 2. It's not one of those. So I know 3 is the number.
3 was in the right place.
And 3 was in the right place. So I go 4, 5, 3, just for the heck of it. Well, looks like those 2 were right, but how about 5, 4, 3?
How do you do that?
No, how about
6,
6?
4,
6, 4, 3. 4, 4, 3.
Yeah. I think Phil's probably right. There's the man. Yeah. Okay, that's one version, and believe me, it's a lot of fun. There's another version of this thing, and all I do is clear. This is all on the same plug-in. It's a 2-player game. The rules now, it's a secret number, so I'm going to enter a number. Okay, now the second player enters his secret number on the B keyboard. The idea now is I try to guess his number before he guesses mine. And you have as many plays until I guess his or he guesses mine. The third one on this plug-in then is a 9-digit number in random sequence, and I try to get it in the straight numeric sequence in as few turns as possible. And I can reverse any string of the number. So the first thing I'll do is put a 2 in there, get the 9 in front, and then move it to the rear, and then get the 8 in sequence. You try to do that in the fewest number of plays as possible. Okay, that's the numbers puzzle in the arcade series. Okay, let me hit this Space War one for just a minute. Okay, this is a spaceship moving across. I have 20 shots to try to get the maximum score. Only 50 of those missiles will go across there, not missiles, spaceships. The faster and the smaller it is, the higher my score. So I fire with 2 on the 1 keyboard, and then I steer it with 4 and 6. Yep.
The big slow ones are really hard to hit.
That's right. That's my man. Okay, that's, we call it a horizontal space war. You also have a vertical version of this. This is a two-player game. Now, this little flying saucer goes up and hits the top 8 times. What I try to do, both of us are going to fire at it and try to hit it. You'll notice every time you hit it, it reverses direction. So there's a possibility, if I'm playing it right, that I can keep the thing from hitting the top. In other words, it goes to the top 8 times. Both of us are trying to fire, and obviously what we're trying to do is to get score. And this is as it moves up, I missed him.
You're gonna
I, I went right through it. Okay, the other one in the Schoolhouse series. Now, if you get into programs like this, and I think you can see the advantage of the 2 digital keyboards, because now we can do some educational things. And if we can have one of those slides. Okay, on this test, the first an S will appear, and I have a choice of the speed to answer the question. So I'm going to say it's 20 seconds. Okay, test. I'm going to look at test 4. Okay, test 4 then, and in random sequence, and we'll supply books of material for the kids. The question is 8s. So Colorado, what's the capital of Colorado? And it's Denver, so I put the 4 for Denver corresponding with that capital. Again, the rules are the same as at addition or sum fun. You can play against the computer and see how fast you can answer, or you can play against each other, one player against the other. Okay, can we have the next one? This would be an algebra type thing. We're going through the same thing again. In other words, speed is 2, and now I want test 2.
You're gonna have trouble with this one, Fred.
Okay, 7 plus something equals 9, so it's 2. Pardon me. Yeah. Oh, pardon me. The question is D. Now, incidentally, I hit that with the A keyboard. I'm locked out, so the other player has all the time he needs to answer the question. Of course, the faster, the higher the score. Okay, D again. I think I can get that. What? Oh, E. How about that? Yeah. Oh, I got that too now. Yay. But this again gives you an idea of the educational capability of this machine. On the first package that comes out with the Schoolhouse series, we'll have math problems, we'll have state capitals, important rivers, this kind of thing. And I think this will help convince a parent that he should buy this game, that he's going to enjoy himself, and he'll spend $150 for it. In addition to that, Andy and the boys, we have a Pong game now that we can sell as a plug-in, or we may package it with the original set. On the Pong game, it has paddle size control, it has speed control, 3 degrees of speed control. You can play with or without English. In addition to that, we have well, of course, the casino games that I mentioned that we're working on. We have a couple more versions of space war type thing. We have a haunted house type game. The fellows are having a lot of fun developing software, I think, that's considerably better than what we have in the built-in machine. And I think that's going to be good. So I say, I'm very, very confident. And of course, now I have to sell it. When I first got interested in Fred, I thought they named it after me. Winder and Weisbecker said, hey, we got something we want you to look at, and it's named after you. I just found out today that that's no longer true. But I still feel now that I'll be responsible for selling this product, that we really have a winner, and thanks for the help. Now, Paul, I'd like to have You, if you would.
Well, we've now reached a point where we can include these two exciting new products, Citizens Band and Studio 2, in our business forecast. And if I can have the next slide, I'd like to show you what it does to our total sales. This is our sales over the last 5 years and our projections for the next 3. As you can see from the chart, these new products have reversed the trend for us. But you got to remember that many of the businesses in this are stable businesses and could fall off a lot faster than we have projected them to do right now. And we still need help, and we need it badly. I'd like to mention a few areas where I think you could be helpful to us. If you recall, I told you one of the big problems on CBs was the fact that we're completely dependent on Japanese production. And this is because of the high labor content in the CB radio. And the next slide shows you what the inside of our present CBs look like. Got another Bow me up. That ain't exactly a 10-4, buddy. Well, somewhere we got a slide that shows you what the CB looks like. You gonna get it? Well, anyway, let's go back. Our present CB contains over 400 components in this thing. Now, this might not be horse and buggy engineering, but it certainly is Model T. Now, most of our competitors, like Johnson, Midland, Pace, and Cobra, don't have the engineering talent to improve on this. But now, however, GE and Motorola are running this business, and they do have the talent. And sometime soon, one of them is going to design a CB transceiver using a few chips instead of all these components. RCA has an opportunity to be the first to do this and give us a real innovative product. I think it would be a shame when we have all this engineering capability to lose the leadership to GE or Motorola. The second opportunity we have is started with Studio 2. This is the first real use of a microprocessor in our daily home life. And I'm sure there are many other applications that can be explored. No one in the consumer product industry has the engineering strength that we have in our laboratories here. And I think we should address ourselves to the challenge of having RCA be the first with a series of products making use of this microprocessor in our homes. I'm sure many of you have had ideas, and we do not in our division have the engineering strength for the research and development necessary. But if you can do this part, we will do what we can to translate it into a consumer product with sales opportunities. In addition to this, we're looking for some other innovations, such as color in the Studio 2. The state-of-the-art CB, which we really need. We'd like to see a 5-function remote indicating low-cost weather station that would entail the development of suitable sensors for wind speed, direction, temperature, humidity, and pressure. We'd like to see low-cost gas analyzers for consumer use for the automobile, and for a flue gas analyzer for home heating to make sure our systems are working efficiently. We'd like to see a low-cost, easily installed miles per gallon indicator for automobiles. Perhaps a keyless lock that could be sold competitively with conventional locks in our homes today. We'd like to see an electrostatic type household cleaner that could replace the vacuum cleaner. We'd like to see a motor vehicle emergency alert system which would sound an audible alarm inside a closed vehicle upon the approach of an emergency vehicle. This would be both an OEM device to be built into cars and an add-on feature for existing cars. We'd like to see a security alert system operating on a signature system. Some work has been done on this, but using a low-cost, easily installed sensors, operating in conjunction with microprocessors. We can go on and on with a laundry list. I feel like I'm making up a list for Santa Claus of things I'd like to have for Christmas. But these are the challenges and the opportunities that we see ahead of us. I'm sure there are more ideas up here than we could possibly dream up. But I think it's a real challenge facing us right now. If we can couple our business abilities as entrepreneurs with your engineering capability, we have a combination that's going to outdistance any competitor we have or will have in the field. And for Studio 2, thank you. For what's coming after this, thank you also.
but I mean the warehouse has come a long way. Looks like it's gonna go further. Paul, I'd like to thank you and Phil and Dave, Fred for a great colloquium, and I think we'll skip the questions because we have our...
Okay, thank you, Bill. Thank you, guys.